All right, we're going to do a short review of set builder notation. And set builder notation is just defined as a shorthand way that we can use to describe an element of a set, a single element of a set. If you can remember, a set is a list of well-defined objects. And well-defined means that I can decide whether or not an element belongs in my set. And so we need to find some way to be able to determine whether or not an element belongs in a set. And one way is to list a set in common notation. So let's say, for instance, that I have a set A, and it is made up of 1, 2, 3, 4, 5, and 6. I can obviously, given a particular element, I can determine whether or not something belongs in here. But sometimes there are so many elements in our sets, 100 or 1,000 or 10,000, that it's not going to be easy for us to write it in this common set notation. And so we need to be able to have a way to determine mathematically, or we need a way to be able to decide if an element belongs in a set. And so this is where set builder notation comes in. And so I'm going to say A is the set of all X. I'm going to put the curly brace, such that, and then I'm going to define what X can be. So just by looking at my set, I can see that X is an integer. I can see that it's not a floating point and it's not a letter. It is an integer. And I'm also going to say that X, I can tell that X is greater than 0. And I also can tell that X is less than or equal to 6. This set builder notation is a mathematical formula or a description that allows me to decide whether an element belongs in there. So given the value 415, I can tell that 415 is an integer, and it definitely is greater than 0, but it's not less than or equal to 6, so that would not belong in here. Also, given the letter B, I can tell that B is not an integer, therefore it does not belong in this set. Another way that I can use to describe this that might be slightly more mathematical is that X is an element such that, first of all, X is going to be an element in Z plus. That was a common set that we defined as all positive integers. And then I'm going to use a comma to separate it from the fact that I don't have to say that X is greater than 0. Because X is an element in Z plus, that means that it has to be a positive integer. So I'm just going to follow this up with X is less than or equal to 6. And this is another way that I can describe an element in A. All right, let's try another one, see if we can get another example. I'm going to start with the set B, and I'm going to say that B is, let's see, we'll say 1, 4, 9, 16, 25, 36, and 49. Now, this pattern may be familiar to you, but we're going to use set builder notation to determine what that pattern is. So I'm going to re-describe it in set builder notation by saying B is the set of all X such that X is, and then I have to try to find what that pattern is that is generating my set right above it. Well, I can tell that it's positive numbers, and so I am going to say that X is an element in Z plus. And then I can tell that I am using the squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so forth, all the way up to 7 squared. So I can tell that there's some kind of a square root, or excuse me, a square that's going on. And so I'm going to define X as, I can't say X squared, but what I can say is Y squared. Now I am going to have to define what Y is so that I can determine if I square it, whether or not it's going to give me an X that is a element in my set. And so I'm going to say where. Well, first of all, I can see that the smallest value of Y to be squared is going to be 1 squared, which means that it's not going to be 0 and it's not going to be a negative number. So I'm going to say where Y is an element in Z plus. This is one way that I can say that Y cannot be 0 and it cannot be negative. And I can also say that Y is not a letter and it's not a tree or something like that. So I'm also going to say and Y is going to have to be less than or equal to 7. Because if I make Y able to be 8, 8 squared is not 49. Therefore, the largest value that Y can take on is 7. So I'm going to move my screen up a little bit, give myself a little bit of room, and we're going to define a third set. It doesn't have to be a mathematical calculation. Let's say, for instance, C is the set of all X such that X is a red truck in the A2 parking lot. I should probably specify in the Weber State Ogden campus A2 parking lot. Now, given any particular object, I can tell, based upon this definition in my set builder notation, I can tell whether or not it belongs in the set. If somebody were to give me a green truck in the A1 parking lot, I can tell based on this definition that it doesn't belong. If somebody were to give me the number 455, I can tell that 455 is also not a red truck in the A2 parking lot. So the whole point behind set builder notation is it's a description, either mathematical or just plain language English, that allows me to determine whether or not a given element belongs in the set or whether or not an element is in a set. So it's not always easy to come up with this algorithm, this mathematical formula for the elements of a set. It's not always simple, but it is an excellent way for me to create a well-defined list of objects. Let me know if you have any questions.